A lot. Alright, here's what you need to know about trigonometry. This is the fastest, dirtiest trigonometry course you will ever take. Trig. The sum total of trig that you need for doing computer coding can basically be encapsulated by this idea. Here's a circle. It has a radius r, and this radius r, I'm going to assume, is sitting on some kind of xy, and it's up by an angle theta. Okay, fine. Processing works this way.
So the angle's down.
So of course theta then rotates this way. Keep in mind if you're doing this in math class, it'll be flipped over because reasons. Okay, so what I need to know is what are the coordinates of this dot here? Assuming that this is 0, 0 to start with.
R cos theta, R sin theta.
Okay, cool. So this is r times cosine of theta, comma r times sine of theta. Just assume that. I'm not going to go into why that's true. It doesn't actually matter. What you guys need is just to know that that's the case. Okay. If you, instead of assuming that this is at 0, 0, assume that this is at some point a comma b, then the coordinates for the x over here are, instead of starting at 0, 0 and going over by r times cosine theta, they start at a and go over r, so you add an a in the case that your circle is centered at a comma b. What about the y? Add a b. Cool. Kick ass. Alright. One further thing. Angles get measured in either radians or degrees. You want to know which one you're working in. It doesn't particularly matter to me that you know what the difference between radians and degrees are, only that you know that it matters which one you're working in. Does that make sense? So you, essentially in trig class I tell you to make sure you check the mode that your calculator's in 1,000,000 times. In computer programming, I'm going to tell you, check the language you're writing in for whether it's in degrees or radians. That's what's going to matter. You guys all kind of good with that? Okay, which one is processing here?
Radians.
Yeah, processing runs in radians. And maybe I should quick sketch out a radian. Well, maybe let me sketch out all the way around. So the a full rotation, right? One full rotation is in degrees, 360 degrees. And in radians, it's tau. 2 pi or tau.
Tau. Technically correct.
Yeah. So it's 2 pi radians. How big a number is 2 pi?
6.28 roughly.
Yeah, it's about 6.28, right? So if you think, okay, 1 radian, right, is about how many degrees?
Wait, but it's 6.28. Wait, no, 6.2830.
No, don't worry about it.
Yeah.
So, point is, 1 radian is about 1/6 of the way around the circle, right?
Also, processing does have pi, so you don't have to type that out.
Yeah, and processing does at least have a built-in pi.
3,
Not
1,
particularly important.
8.
Great, great, not important. All I want to know is what a radian is in degrees. What's a radian in degrees? It's about 1/6 of the way around the circle.
60-ish.
Yeah, which is about 1/6 of 360. So it's about 60 degrees. So if you see weird jumping behavior when you're trying to code rotation, Usually what's up there is you've coded in, you're like iterating through radians instead of iterating through degrees. It's cool that? And you can typecast, so it's worth knowing that if you have a number in degrees, if you want to feed this into a trig function in processing, you want to in the middle put a typecast to radians, right? So that the casting is radian. That's not actually a typecast, right? It's just it's like a unit conversion, which we could figure out, but I don't care if you know this. I just care that you know you need to do this, otherwise things will act all jiggery. You guys cool with this? Questions, things? Okay, this is exactly what I need you to know from trigonometry. Oh, maybe one more thing. One more small thing. If you have some known distances, right? Like some kind of a, I don't know, like an x and a y, and you want to get this angle here.
A squared plus b squared plus c squared.
That'll give you this distance here, right? So this distance is the square root of x squared plus y squared.
Pythagoras.
And then where do you get the angle from? The angle here you get out of doing arctangent. So theta is arctangent of y over x. And what you need to know is that there's an arctangent function built into processing that you should read the API for.
There's 2 of them too.
And there's 2 of them. One works like this, where it takes a y over x number. Like it takes one number that you calculate, that's y divided by x. And then there's another one that takes 2 arguments. The one that takes 2 arguments is probably the better function. So if you want to figure out how that works, it's in the API under ATAN2. I think this is the name of the processing function.
Does it just say the y and then the x?
Yeah, it takes a y and then an x, I think. If you're using it, go check in the API. Cool.
It takes a position, 2 positions.
It takes a y and an x and then returns the angle here. You guys want to play with this a little bit? Okay.